Hi everyone, this is James Whippen here for CG Tuts, and today I'll be talking about dealing with barrel distortion. And barrel distortion is caused by wide-angle lenses, and it's distortion, as you can see here, that occurs around the edges of the frame. Things that are supposed to be straight appear warped, and you can notice this especially in this example piece of footage that I have here walking down an alley. And yeah, as I said, it was caused by a wide-angle lens. This lens here is the WDH43, which isn't even that. It's not a very extreme wide-angle lens, but you can still very evidently see the artifacting that it's causing. And with some other lenses, like if you had a 4mm lens, this would just be absolutely insane. And the problem with barrel distortion is if you try and match move it, we're actually getting an inaccurate representation of what the scene is actually like. If we were to look at this and try and determine what the scene is, we might think that things in the corner are actually bent or wobbly, but it's not the case. They're actually straight, and anything in the edges just appears to be distorted. So that's a problem, A, for match moving, and B, if you put elements into the scene, even if you had it match moved correctly, those elements wouldn't have the same distortion near the edges, and therefore would glide and shift unnaturally. So a good way to work with this barrel distortion is to remove it first from the footage, correct the footage, then match move it, place the CG in, and then reintroduce the barrel distortion to both the footage and the CG together, and that will create a very natural looking effect. So let's have a look at the footage we'll be working with. As an example, we'll be adding or compositing some 3D CG elements into the bottom right hand corner of this chessboard. As you can see, a chessboard is a good example because it has very strong horizontal lines with the checkerboard here, which highlight the distortion, and also the bottom right corner is the place that suffers. As you know, the corners suffer the most from this effect, and that's where we'll be compositing the CG, just to highlight the importance of dealing with barrel distortion. So to get started in After Effects, there's an effect called optics compensation, and this compensates or overcompensates or undercompensates for barrel distortion any way you like. So it's pretty simple. It's just you change the field of view, and you can see we're actually adding barrel distortion here, and to remove it we reverse the lens distortion and we increase it here, the value. And to be able to know which value you need to which is the correct value for your particular setup, it's handy to have a distortion grid. And a distortion grid is just a grid that you film, and then that'll help you determine the correct amount of compensation you want to get rid of the barrel distortion. So while we could guess and say, oh, this looks about right here at 37.1, we could probably get a more accurate result by doing the optics compensation on the actual distortion grid. Here's my distortion grid that I've set up, and I've actually drawn this, but you could print it off on the computer. And basically it's just a grid. I think it's 1 centimeter by 1 centimeter, and I've made it the correct aspect ratio for the footage. So it's 192 millimeters by 108 millimeters. And it's a good idea to have it stuck up against a wall or something flat, so that you know when you put the camera on the tripod you're going to be looking at it front on. If it's like on an angle or something, it's going to be less accurate. And then I've set up a tripod here, so I can try and get it as front onto the distortion grid. And pretty much what you want to do is just get it as close to the edges as possible. Now this actually might be quite tricky because on my camera, the Canon HV40, the viewfinder is actually a little bit inaccurate. So a bit of trial and error, and I just did the best I could. I kind of lined it up, and then I actually had it on the tripod.
I'm just holding it in my hand for demonstration purposes, and I just set it there for about 5 seconds.
Alright, I've logged the footage and just taken a still here. We just got single frame, single TIFF, and you'll see that I didn't get it totally perfect. It's quite crooked, but avoid the temptation to just to correct it, because you're actually rotating the barrel distortion with it. We want to keep it natural. So it's a little bit annoying. It's better if you have it perfect, but we can still work with this. So if we add an adjustment layer, sorry, a solid, and use this as a guide, I'll just use the Y, the pan behind tool, to move the anchor point. We can get a guide of what is actually straight for us. So just lining this up here with the bottom line that we have to try and find out what is straight. I might add the levels adjustment to the background, sorry, to the distortion grid, so we can enhance the lines, and that's looking pretty good. So because of the wobble, this is now straight, the angle of 0.6. So when we well, this is the distortion that we have here. As you can see, this big wobble, we want to remove that and make it in line with this white solid. So let's add the optics compensation, and we're going to be removing it, reversing the distortion. Now with the field of view, you can actually calculate it. There's various calculators online to work out your field of view and the maths here. So it's field of view, and we're using a rectilinear lens. I'm not sure if that's how you say it, but yeah, that's what pretty much everyone's lens will be, unless you've got some odd lens. And it's 2 times arctan times the frame size divided by the focal length times 2.
You could also use the calculator that they provide down here, which is where you feed in the focal length, the multiplier, which is in our case 0.7, as we're using a wide-angle lens, and also the distance to the subject, which will vary each time you shoot. So when I was filming this, I didn't actually record the distance to the subject, and also it'll vary in your shot. The camera might start out close and then end up far away. So we're just going to eyeball it.
So I'll just increase this value, which is something that looks good, and I'll move the solid down to see if we're looking good. Yep, that's looking pretty good. So as you can see, we get the horizontal correct, but the vertical still has a little bit. But there's actually nothing we can do about that, because you know, if we made it correct for the vertical, we're not going to get it right for the horizontal. So a good thing to do is to save this as a preset, so anytime you're using the same hardware or the same settings, in my case HV40 with the WD-H43, I can just slap this on and not worry about using the distortion grid and such. So just go animation, save animation preset, and I've already got one here. I'm just going to overwrite that. So we've got this footage here that we want to work with. I'm just going to type in fix, and you can see I've named it under the camera and the lens, just so if you happen to have multiple cameras, I don't, unfortunately, you know which one you're working with. Okay, so now we can see the effect that it's had. That's before and that's after. We're still getting a tiny little bit of errors, but this is, as I say, this is as good as we can get it. It's mainly in the vertical. But if we make the composition a little bit bigger, we can see what this is doing. If we turn on the resize, and it's pretty much just stretching it, pinching in the edges and stretching it to reverse the barrel distortion. And you could feed the match mover this extra information here on the edges, but this is the bit that has the most distortion, so I'm not going to do that. I'm just going to say this is my corrected footage, and we're going to match move this. So let's save this out as a sequence and bring it into PFTrack. Okay, here's the footage in PFTrack. I'm just going to quickly auto-track this. Alright, I finished that. Let's go to the track editor and cull the threshold down a little bit so we don't get some of these less accurate trackers. And let's just go camera estimate focal length so we can set our ground plane, help ourselves and help PFTrack in the process. And I want to make this pretty big. I might start here, and then use these squares here, so a 4x4 grid here. Okay, and let's just hit solve motion. Okay, here we have it. It's looking pretty good. Let's export this. I'm going to be using Maya features. I don't really need any of the features, so I'm just going to go none, and let's save that.
I've just opened up the PFTrack camera data in Maya, and I've just put some simple geometry and some simple lighting here. And we can't just render this out, because if we jump back into After Effects for a sec, remember that there's actually footage that goes off the screen here, and we need to render CG for that. So if we just rendered 1920 by 1080, we wouldn't be rendering CG over the pinched edges. So we need to render our CG out larger than our final output format, so that we can cover all the footage. So in this example, we want to output this at 1080. So we're going to have to make it the CG larger than 1080. And because rendering time is expensive, we don't want to render it. We don't want to just go, oh, just render it in 4K and then our bases will be covered. We want to just render it just what we need. So for this example, where we don't have too much barrel distortion, I say we might need to render it out 20% larger. So let's go 1920 times 1.2, and we get a value of 2304. So I'm going to type in 2304, and if you have the lock aspect ratio, it gives you the height for free. And we can see here that, yep, we've got all our bases covered. We might have a little bit more than we need. We could just say, oh, let's increase it by 17.521%, but it's just easy to remember to increase it by only 20%. So 2304 is our value that we need to output the CG at. So back in Maya, I'm going to go to the Render Settings tab, and if we remember to maintain width-height ratio, we can just type in 2304 in here. Now, it's not good enough just to increase the resolution. We also need to increase the camera, or what the camera is seeing, by 20% as well. And then once we increase the resolution by 20%, which we've already done, then we'll get the good result that we need. So to do that, I'm going to go to the Camera Settings tab, and the camera scale, I'm just going to make 1.2, which is 120%. Which is the 100% increased by 20%. So if we look here, when we change that value, we could see the scene scale. We've increased the resolution here to 2304, so we're ready to render. Alright, the CG is finished rendering. Let's drag it in here and do a quick preview. It's looking nice. Now, ideally, we'd like to reintroduce the lens distortion at 1080, so we could see exactly how much we need to add to get the best possible quality. But unfortunately, because it's using an adjustment layer, because we're using two layers, we don't want to do an individual fix on each. We just want to do the adjustment on one adjustment layer, and everything below is affected by it. And the reason we can't just do it at 1080 is because the adjustment layer works on everything it sees. And if we did it at 1080, the adjustment layer wouldn't be seeing these edges here. So we're going to be compositing it at 2304 resolution, and then we'll add it into a 1080 composition for final output. So let's add the fix that we have, and we can just uncheck the reverse lens distortion. You'd think that it would make it perfectly perfectly reverse the effects, but unfortunately this value isn't actually correct. And also, it's because we did this at a different resolution composition, the 1080 comp, the view center is also incorrect. So let's add the optics compensation itself, and we can just quickly copy these values here. So now with our distortion fix, it's got the correct view center, but we can see that it's still wobbly, and that's unfortunate. So we'll have to actually increase the value here. So I'll increase it a little bit, just trying to eyeball it, and pretty much what you'll need to do is take this corrected footage into a new composition and scale it down to 1080. And we can see that we're completely safe here, so let's crank it up a little bit more. Let's take it to 54, let's take it to 55, You can see that we're actually we need to lower it a little bit because we're getting, if we turn the alpha on and off, we can see that we're getting this edge here. So let's take it to 54, and we can't see the edge anymore, so that's about as good as we're going to get it. So let's take a preview at our wide angle CG. It's looking really good. If we go to the last frame here, zoom in 100%, and we take a screenshot and we turn the CG off, we can see that just slightly, I'm not sure if you can see this on the recording, but there it's actually getting some of the soft shadows of the final gather over here. And if we didn't increase the size of the footage by 20%, we actually wouldn't have rendered anything on the extreme edges. So it's really important to scale up your footage. And I'll just turn this back on. And it's really also cool to see what effect this adjustment layer is having on the CG footage. And that's it before. This is what we rendered from Maya, and this is reintroducing the distortion. So I think that's pretty much it. That's the end of the tutorial. I hope you've enjoyed it and learned something. Thanks for watching.